Welcome everyone to this Software Circus new edition. Once more, we're partnering with GOTO Amsterdam for this one, and we have two great talks about serverless for you tonight. A couple of things I want to share is, of course, as usual, Software Circus is always looking for speakers. So if you have a talk or if you know someone that does, please send them our way. We're going to have some fun hosting your talks at Software Circus. So this is how you can join us, either through Meetup. I'm sure a lot of you are already in there and have received all our messages. Twitter and email are always good solutions. And as I announced last week, we now have a permanent call for speakers through a form, a Google form that we published this morning, actually. I'm sure some of you have received the messages we sent through Meetup. I also sent a tweet about it, so you have our Twitter channel right here. If you haven't received it, just go in there and you will find our permanent form for speakers. We will share it again throughout the weeks and upcoming time. And so before this is actually going to happen, Natalie is going to share a slide with us, but after that we're going to have two talks. The first one is going to be by Andrey about serverless patterns, and the second one is going to be by Jojo about the state of open source serverless. To you, Natalie.
Okay, I'm not that. I just prepared one little slide. So GOTO Amsterdam was going to take place in June. Obviously, it won't happen anymore, but we were able to postpone it to December. So GOTO Amsterdam will happen December 7th to 9th. Crossing all the fingers that everything works well. And Sam does have a discount code to share with you guys later. And yeah, so you'll just get an email with a 10% discount code. If you have any questions, ask me at nat@trifork.com. I should be also in the meetup. Just, yeah, you'll find me. Shoot me a message. Cool, that's me. And before we start, Andrey is one of our speakers, so I'm very excited he's here, and I thank you very much for participating.
Thank you for inviting me. Okay, so do you hear me, right?
Yes.
Yep.
Cool, so let me share my screen. And you should see now my super designed slide. One color, right? Two colors. Right, so let's talk about serverless, and I guess most of people who've joined this meetup webinar actually at least have heard the term or know at least something about that. So I will not focus too much on definitions. Okay, I will a bit, but I will then jump into the patterns. So who am I? I am myself working as a developer and as a consultant, and like in the last few years, I'm doing a lot of things that is related to infrastructure and automation and software delivery pipelines. So some people would call me a DevOps guy, but anyway, I'm still a developer, still have a development mindset, and I still look at everything as it is code. And in regard to serverless, I actually have several serverless deployments that are either open source or commercial, and I kind of collected some experience in this area that I want to share with you guys, with you folks. Also, another things that I do from time to time, I'm training. I'm doing courses on DevOps, automation, and stuff like that. Speaking from time to time and doing some other stuff. But okay, we have only 30 minutes, more or less, so I would like to focus more on the topic of this talk. Right, so let's start. So what's serverless? And the funny thing that if you ask many different people, you probably get a gazillion different opinions on what it is. And well, the funny thing that the term itself is quite confusing. That obviously serverless means no servers, and obviously it doesn't mean that you just throw away all of your machines and start, you know, deploying to a mythical cloud and everything works out of the box. Obviously, servers are still there. the thing is that we just want to care less about their existence. We want to care less about how to configure them, how to patch them, how to scale them, how to connect them to the network and stuff like that. And obviously we are on that level of development as a civilization that we can actually do that right now, especially that with all the platforms that appear now, both cloud provided and the ones that you can build on your own. All of them allow a lot of different patterns, a lot of different things that would still be possible with servers, but without servers, they are bringing you quite close, much closer to the idea that you want to implement your business, to bring your business value much faster than with them. On the other hand, maybe most of you know and worked with containers, and I guess most of you have at least heard about Kubernetes. The thing is that serverless may also mean that you are actually not using containers or not using any kind of orchestrators. You're just deploying your code directly to the platform that that does things for you. And well, that could be, you know, the serverless kind of raising the bar of abstraction that hides all the operational details from you, but gives you the platform where you can scale your idea, scale your business, get the value much faster than compared to the environment where you have to care about all these tiny things like Docker containers and server operating systems and stuff like that. Also, despite of all things that, you know, serverless environments usually are cheaper, they're definitely not costless because you have to pay for that, absolutely. Also, many people associate serverless environments with function as a service, where you just run your function as code and then some sort of platform, and that's it. But the thing is that actually serverless is way more than that, because serverless in order to run a function as a service, you definitely would need some additional services that would require setup or maintenance of some sort. And then in that sense, serverless definitely doesn't mean operationless, because of course, if you're running some small piece of code, that's easy to run, that's easy to deploy, and that's probably will be operationless. But if you're running something that is a bit more serious, something that's a bit more advanced, you would need to configure additional resources, additional services, and you will have to audit them. You will have to control them. You'll have to, you know, calculate the budget, calculate the cost, and of course, it will require some level of operations, which will probably be easier comparing to what you would have to do with real infrastructure, real. Well, I mean, it's still real. Everything is real, but with servers, it would definitely be more involved, and you will have to have special people, special team members who would have expertise in maintaining servers, in maintaining networks, in maintaining data storages and stuff like that. But with serverless platforms, you at least can hide part of that behind the abstraction, behind the platform abstraction, that would simplify certain things. Right. One way I really like looking at serverless is that it's not really about absence of servers. It's more like consumption of services. And the more services you consume, the more serverless you are. That's kind of, you know, ridiculous comparison, but that's true. And also some other aspects of serverless environments, serverless platforms that you would probably notice is that serverless usually is event-driven. So of course, the early implementation of serverless platforms, serverless functions as a service implementations, they were driven by request response kind of things. But with serverless growth, with functions as a service platform maturing, of course, you want to react not just to an invocation of a HTTP client. You actually want to react to any kind of events. And those events can be well, anything. It could be a database record being inserted into the database, could be a file uploaded to storage, could be email received and stuff like that. I mean, a lot of things could happen. It could be other functions sending you another event. And of course, serverless by definition should be event-driven, because that's how it can scale to and can be deployed in the most efficient fashion. Also, another aspect of serverless that people quite often miss is that serverless is not just running your code in some platform. Serverless is really very much the usage of serverless services is very much attached to the way you pay for them. So it's basically pay-as-you-go model, and obviously, if you have to start a server that is standing there and you're paying for that all the time, it's not serverless, and it doesn't count as a serverless, because even if you run some sort of Kubernetes on top of that, because whenever your Kubernetes is not loaded, you pay for the whole cluster. And with serverless platforms, the more serverless you are, the more your usage of the platform is attached to the amount of money that you pay for that platform. And that is related not only to like function as a service, also related to database as a service, storage as a service, and many other things that you can consume as a service. Also, usually in serverless platforms, you would get some sort of control plane, some sort of UI or dashboard that will allow you to observe what's happening in your platform, what's happening with the function, what's happening with the database. And again, that's something that you have to set up yourself if you are managing that on a server level, infrastructure level. Right. And serverless provides a lot of built-in things that are not available or have to be set up in their own way when you configure that on your own. Right. So you probably will if you explore the serverless domain for a while, you will see that people are defining serverless as a spectrum. It's not a boolean. You cannot be either serverless or not. You probably are somewhere in between, and you probably use different compute models. Serverless is kind of it's an operational construct that can be implemented on the platform level, and it can be implemented also on in the cloud. And so it can be on premise if you want that. Also, usually it is a billing model because you pay as you go, and it's an architectural style because most likely it will require to restructure your monolithic application or restructure your application in general to adjust to the serverless execution model, because it's not possible to execute your application right away. Right, I'll probably skip this slide, but yeah, that's one of the things. Now, one of the observations that I have during my consultancy is that most of companies, and pretty much every one of them, is actually having some sort of serverless deployment in the last 3 years. And I mean, it is related to big companies and also to small companies. And mostly small companies are kind of looking into the direction of serverless because it seems like it's a cheap solution and cheap way to start. But also big companies are looking into that direction because it brings flexibility, it brings predictability, and it also delegates part of platform support to cloud providers or to platform teams. So pretty much every organization that I met so far in my consulting businesses is looking into serverless or already have implemented serverless in some sort in production. Right, and as I remember mentioned, like serverless is a spectrum, and you could be somewhere on this level, and we want, of course, to jump closer to the function level, where we run small units of code, and we scale them, and the platform scales us for those small units of code for us, and we are integrated into the event system that is provided by the platform, and of course we can be on any other level, and also again, comparing my experience for different consultancies, is that most likely the bigger the company is, the bigger is the chance that that company will be on every of these levels at the same time. Right, but we're speaking about serverless. We want to be on level 4. We're speaking about mostly function as a service because that's the main component, main execution component that consumes and may consume and customize all other services. Right, and the things that, of course, me as a developer, and most likely you folks also as developers, want to focus on the code, and that's what most of the serverless platforms actually allow us to do. But of course, eventually, it's an abstraction, but it's kind of a leaking abstraction because you eventually have to think about other integration that you have to make. How you have to optimize your code to run inside the serverless platform. You have to consume the services that are good enough for all your integrations. That's the decision that you have to make eventually. The good things about serverless platforms, of course, that you have a lot of things that are built in, and I mentioned them already briefly, but also other things that you have to buy in, and they of course will consume they will expose another cost on top of the function as a service cost. So database storage, messaging, all of these things you cannot really put into a function. You have to implement them. You have to consume them as other services, or you have to implement them on using some more traditional approaches like hardware or virtual machines. And the thing is that function as a service is not just running some code by itself. Of course, you have to have certain services that usually any function as a service platform has. And that's obviously the function storage where you store the code. There could be also the way your functions are getting traffic from outside. Different levels of security. Obviously, there should be also an event bus, so all the functions can communicate with each other over event bus, and also expose events and consume events from outside. And also, it's kind of important that your function as a service platform provides you a way to store your code and get automatic deployments through pipelines, and get an easy pipeline in integration with the platform. And most likely.
Can I just ask you to talk a bit slower?
I'm too fast, sorry.
You're too fast. I tried sending it to you as a message, but I thought I'd just interrupt. Everyone is so glued on what you're saying, but you're super fast.
Okay. Because
sorry.
Yeah, it's fine. It's feedback, right. So I'll try to be slower, and just I have a clock here near me, so I'm like 80 minutes left, and I'm looking at that. Yeah, it's making me fast. Maybe I should switch off the clock.
You can go more in the talk and then less in the Q&A. So no stress.
Okay. No stress. Right. So these are the elements of functions as a service platform that you would find in pretty much any platform that is mature enough. And that's actually something that you should expect as well to be there, because if it's not there, then most likely functions as a service platform will be less usable and less pleasant to use. But okay, let's talk about the patterns. I hope you pretty much most of you understand that that the way we deploy the function is that we deploy a small unit of code, but that small unit of code can potentially live in different places. And the first thing you have to decide if you want to at least try to go in the serverless architecture, serverless platform, is that where your platform is going to be. Right. And of course, there are ready-made platforms out there already, and some of them are quite mature. For example, the Amazon Web Services, they introduced function as a service platform back in 2015, and also the services that were surrounding that Amazon Lambda functions, they also gave a lot of functionality, a lot of features to that platform. GCP, Google Cloud also introduced cloud functions. I think it was 2016 or 2017, if I'm not mistaken. Azure has that, IBM Cloud has that, but also they apart from execution model, they also provide a lot of services that your function can consume. And the richest one of them, of course, is Amazon at the moment. It has very many integrations, very many patterns that you can support with that. But you're not limited to that. And of course, there are some companies that are deciding that, of course, well, Amazon is good, Google is good, but maybe we're not ready for that, or we're not allowed to use the cloud for some legal reasons. And then in that case, you can probably implement a serverless experience, a serverless platform on your own. And there are existing ones. There are existing ones that you can actually run, most likely based on Docker, based on Kubernetes. And like one of them is Kubeless, another one is OpenFast, which is probably the most popular implementation of serverless experience. And the thing is that, of course, that you still have to configure your servers where you run a Kubernetes cluster, and then where you run your serverless platform. And so the cost is going to be quite big, to be honest. But at the same time, if you want to provide your developers, your project, an environment where they can deploy and experiment quickly, and when your platform team that is supporting all this setup and your development teams are isolated by a contract that they will use the platform through a serverless paradigm, then this could be a way to also make a company move faster and make some decisions easier, and some investment into the platform may eventually pay off after investing in that. So some companies choose that one. But also it's quite possible that you are maybe a small startup, maybe a small company, or maybe a big company that is implementing some sort of project, and you may end up actually consuming a lot of services that are running on different platforms. For example, it could be a Cloudflare CDN provider that is doing edge workers, where you can run your code close to the content, to the client that consumes your content, and then make some logic, some decisions depending on which country your customer is coming from. For example, you can integrate that with webhooks, and then you can get database as a service. You can get metrics as a service. You can get search as a service. You can get like some sort of function as a service with managed platform like if this then that, where you can visually design your logic and integrate with different other providers. So theoretically, you can also call these things, call these multi-vendor integrations, which are not specifically cloud providers. You can also call that a serverless integration, and this will really it will kind of the world becomes your platform, because you consume services from different providers, and maybe with a bit of code, maybe with a bit of configuration, but still it's a quite a valid pattern. And I've seen many companies choosing that when the use cases are not that big, or the service provider meets exactly the needs of their business requirements. Then it's easy to consume the service and to consume it with a bit of code or no code at all. So again, your company may be in any of these situations, or at the same time, it could be that you are implementing all of these patterns at the same time. But the first thing, of course, you have to decide where you are, and what you want, what your project is going to be. Right. Another thing that, of course, you have to get used to, that your functions, your function code, the code that you write to kind of express your business logic, may consume different types of events. And in platform like Amazon, you will definitely have you will see a lot of different event types, right? And if it's not Amazon, if it's something like GitHub or Mailgun, or I don't know, some other service that is exposing APIs or exposing webhooks, then most likely your communication will happen over HTTP. And writing a function that is awaiting HTTP traffic of some sort is quite easy, but you have to expect that events may come at any time, at any point, and your function has to be ready for that. And platform kind of helps with that already, but yeah, some gotchas there as well. So events, and I already mentioned that several times. Events can be quite different. So HTTP call, it could be a browser invocation of some sort. So your UI is calling that. Webhook invocation, database event can happen. So actually, it's funny to think about that database triggers were one of the first serverless deployments in the world. When Oracle database triggers, you could trigger the function described in the trigger at any point in time. So it depends how often your database is being populated. So the same kind of thing is possible now at the level of cloud providers. And different database implementations like DynamoDB or Firebase, they allow you to invoke a function if certain database event has happened. The same thing with storage, like S3 buckets, Google storage buckets. You can invoke a function when something is added to or deleted from the bucket. The same with queues and topics. The same with scheduled events. So you can schedule your event in certain time, and then your function will react. So, and if you think about it, I think this is one of the most important patterns here, because of course we can implement all of this with cron jobs, with the messaging solutions, with storage solutions on our servers. But now that we have all these events happening in our platform, we have to also think about how we can factor the code in a way that is just react to a small event, and what other things it will call. And this definitely puts the constraints on how the architecture is being designed for our application. Right. One thing I want to share, another thing I want to share is that how do you package your function? How do you deploy your function? And I found, well, I did many function, like Lambda function deployments and serverless function deployments before, but I recently found this quite interesting talk called Lambda Trilogy. And the funny thing, I actually did all these patterns before, and I like the naming of them, and like how the author put that on. So basically, one way you can deploy your function is that each function deployment will correspond to a small function. Like, for example, in this specific picture, you'll see that a function is doing some simple operation on a calculator. And if it's some other use case, like, I don't know, shopping cart, then it could be like modify shopping cart, add shopping cart, destroy shopping cart, stuff like that. So each business function, each small functionality of your application will be deployed as a function. This brings you a lot of operational flexibility, a lot of deployment flexibility, because you can your functions can scale, and depending on how they're used by your customers, and it really, you really don't care about and you really pay for amount of usage for each of these functions. So it could be like, it's very nice billing mapping, and it's really nice scaling mapping, but at the same time it may provide some inconvenience for developers, because you have to design each of these functions in a separate folder, or maybe even in a separate repository. And imagine if you have like hundreds of functions that you created, and as a developer, jumping between different functions, small functions in the IDE could be not the most exciting experience. One kind of the other side of this spectrum is that you basically put every function, all of your functionality into the same deployment, and you deploy it as a single function, and then your function can respond to different types of endpoints and different types of parameters. And this is actually, this could be a good deployment, because many people associate monoliths with something bad, and lambda lith or function lith is not a bad thing actually. It's just because, well, lambda itself, or function as a service itself, they have some limitations already. And while you are within that limitation, the limitation of size of the function or the memory use in that function, then I think it's a good measure of having a small microservice, because you cannot put a lot of logic there. Well, you can, but still, if you have a lot of dependencies, it's still you will eventually hit the limit. And this, limit of the platform will also be limit on the size of the function in general. So lambda lith is very convenient when you develop a functionality that is connected logically to each other, when you have some logic coupling, and then it's easier for you as a developer to reason about the code and do some local tasks, some integration tasks and stuff like that. With if you're going into the mode of single purpose function, then your functions should be really independent. Otherwise, you risk of investing too much time on jumping between them, and then maybe implementing some library level that is not needed and stuff like that. So both of these templates or the patterns actually are good ones, and it really depends on how you want to organize your teams work on the code, how you want to organize the logic, and what are your operational constraints, what are your scalability constraints. And this is also a nice thing about serverless, and I think nice thing about function as a service is that you as a developer, actually, you don't forget about operational context. You actually have to think about it. You have to think about the cost. You have to think about how you scale it up. And this is coming from the limitations of the platform. And this is absolutely nice thing to me, because this let you think about everything that is involved into running that function in production. Right. I'll probably skip this one. Also, another thing that people are often talking about when we talk about function as a service and function as a service platforms is that there's definitely similarity between the package that you deploy to a platform like Amazon Lambda and a Docker container. And the funny thing that actually Amazon is actually running them. The final Lambda deployment is actually running inside a container, not Docker container, but a container. And it comes natural that why not to package because many developers, many people are familiar with container concept and they know how to use that by now. And the question is coming: why don't you package your function as a container and then deploy that to the platform, and then the platform figures out how to run that? And that's a good question, and I think the industry is still figuring out what is the answer. Because to some extent, it's probably easier that if platform abstracts containers away from you. So you don't care about containers. But on the other hand, containers offer so much flexibility and so much reusability in terms of that you can run a container locally, you can run container in the cluster, you can run container anywhere where the containers are allowed, and that's pretty much everywhere. So that containers Docker containers offer a lot of flexibility and a lot of familiarity to developers to work with. So I think that is still people are deciding, and like maybe there's like mini war happening between how Amazon and Google allowing it to run functions, and whether they should allow to run your containers as functions as well. And for example, not that far, like a year ago about that, Amazon introduced a container service called Fargate, where you can just actually run your containers almost as functions or as tasks, as cron jobs and stuff like that. And that is really merging these two worlds, where you have focus on full on the code, or where you actually have also information about the container, and you create a container yourself. So I think we will have the options, and I think that maybe, well, I'm not sure where it's going, but I guess eventually that we'll be able to run any Docker container as a function in any platform. But that's just my wish. Right, and if you want to run, if you want to have a platform as a service, like function as a service on your own infrastructure, then most of the platforms that I know at the moment, they support Kubernetes, and you can install OpenFaaS or kubeless or Knative as a way to deploy your function as a service to them, if you want that. Right. Another pattern that that is kind of also used quite from time to time, which kind of offers a mix between single purpose function and lambda leaf, is basically you have one deployment. You deploy one package of your code which contains all the logic of your business or specific application, but then from that code, from that piece of code, you actually deploy several functions. So it kind of offers you both worlds. And again, fat may be treated as a negative term, but in this case, I think it's just one of the terms that is actually positive. And actually, all things are positive in the serverless world. That's it. Right. So with Fat Lambda, you basically get the flexibility of having one code base and the business logic being concentrated in a single repository. But at the same time, you get the flexibility of deploying this deployment units in any way you like, and also this also gives you the scalability of these units independently. That's kind of a nice thing. Right. Another thing that I have to implement quite often when I implement complex serverless deployments is that quite often you do not delegate the invocation of the functions to the user. You have some entry point where the user is calling your API or your business functionality or some sort of webhook, and then your other pieces of your functionality are split into smaller functions. And there is there's a special routing function that is serving as an entry point, and then it decides, depending on the request, which function is going to be called. And we can call them functions directly. We can publish a message to a queue, or maybe save file to a storage, and then another function will be invoked. But then the routing function controls the entry point to our logic. Just an example of that. And also, because this routing functionality is quite common, and it could be that you want to control that fully, and you want to implement the logic in the way you like, and you can do that as a function, or you can actually many platforms like Amazon or Google, they actually provide special gateways like API gateways, or event bridge, where you can actually configure the routing logic. If your routing logic is relatively simple, then you can use gateway from the platform to actually send things to your smaller Lambda functions. Another pattern that is actually is implemented as another service by Amazon, by Google, by Azure, is called step functions. Basically, when you have a state machine where your business process is implemented as a state machine, and then your state machine is evoking small functions that are deployed independently. And the thing is that you can implement that yourself if you want. Of course, you have to use some data storage where you store the state of your current business process. But platforms like Amazon and Azure, they actually provide you a service, like state machine as a service. Right. Another thing that I quite often have to solve when I have to write a Lambda function that integrates with different services is like in configuration discovery, and there are many ways to do that. One way would be to actually just bake the whole configuration into the function itself, because functions just usually says it's a zip file or container, and you can put whatever you like in there. And of course, the configuration for the other services can be stored in there. On the other hand, platforms like Amazon, like Google, like Kubernetes, they provide some abstractions with which you can integrate. And for example, in Amazon, you can use as a some parameter store, or you can use external service like Secret Hub, or if you are running your function inside a Kubernetes cluster, you can rely on a config map. Also, another thing you can do, of course, you can just store your configuration on a bucket with most likely the bucket should be encrypted, and only the function should have access to that. And that's another thing. Also, another way to use configuration discovery, of course, if you have to route to different services or different API gateways, you can also use DNS, internal or external. That's another way to do it. But actually, this doesn't differ much from normal code. Normal code can also do like that. Just within Lambda code, the function as a service code, you have to consume more services if you want to have something from outside. Right. Another pattern that I quite often find myself doing is I have to optimize my function code to start as fast as possible, because otherwise platforms usually give some cost on that, because function is starting slower and your users are getting response slower, and that's a good thing. But the anti-pattern that I would say here is trying to over-optimize for that. And I've also been there. And the thing is that if you find yourself over-optimizing the Lambda code, the function code too much, it could be that you actually maybe are using the wrong platform. Because sometimes the use cases are that probably it's better to use normal hardware actually, instead of running things in a serverless mode. And if you find yourself in over-optimizing these things, then maybe it's time to think about some other solutions. Right. How much time do I have? No time.
How long will you take?
Yeah, maybe another 5 minutes if it's okay.
That's fine.
5 minutes is fine.
Okay. Yeah, I'll be quick.
Take your time.
Right. So and another thing that you will end up doing when you want to play with your code in a serverless mode, you will realize that if your function is integrated with many services, you have to test it somehow, especially if it's an event-driven thing and stuff like that. And if you were implementing for Lambda function or a Google Cloud function like maybe 3-4 years ago, you would not have an environment like that. But now you have. Now most of the frameworks, they provide some sort of local testing environment, local simulation environment where you can actually play with resources and at least to some extent simulate stuff. Also, I mean, since most of the functions actually it's just code. You can actually organize your code in a way that you can use abstractions and stuffs and mocks to mock your dependencies, and then do the integration tests or unit tests in function logic in that way. And that's this thing didn't change since normal applications. Another thing that you have to be quite careful with and quite friendly with is that the standard output of your application. Because most of the platforms, actually, I think all of them, the only way to get some output, some debug output or business output or info output from your application is the standard output. And that standard output is usually consumed by the platform. So you can use the UI, log UI, or some sort of log aggregator where you have to look at that. And that kind of adds another rule of discipline that you have to follow when you design your code for serverless environments. Your log stream, your standard output, should be extremely clean and free of noise. And of course, because there's a huge chance that you would call, you will have a mesh of functions that are calling each other. You would have to do some sort of tracing of how these things happen. And usually most of the function service environments, they provide some sort of context, like invocation ID or some sort of what is the request ID, and what is the function name and stuff like that. And you can actually pass that thing over to the log, of course. That's of course, but also to anything that you are invoking. So if you're sending a message to a queue, please just add request ID from your originating function. Then you can trace it easier with log aggregation solutions. Because if you don't do that, I mean, it's really hard to debug serverless deployment of at least like 3-5 functions that are communicating with each other through some mechanism. It's because, well, you have to go through the logs. But if you have these trace IDs in some way, then it becomes easier. Another trick that I do from time to time with especially with chatbots and with the different integrations that are integrated with chat, is that instead of using together with using the console log I'm also using a way just to send important messages to Slack or to any other chat solution. And that kind of, gives me, especially if it's a long running task, which may take 5-10 minutes, and I don't want to sit there and look at the logs when the log appears. I actually just send a Slack message when it's done, and then I'm in the Slack all the time, so it's kind of it's a good indication that I get some notification from there. Right, and this is one example of that. Right, I'll probably skip this thing because well, database as a service is kind of an understandable thing. And of course, when we talk about databases, many people would imagine a database server like Oracle, MySQL, or Postgres running somewhere. But the thing is that the database is also evolving, and you can run database on Kubernetes, and that setup is quite mature at the moment. You can also run database as a service, like Amazon RDS or MongoDB, for example, like Atlas solution, where you get machines provisioned for you and managed for use. But you don't get access to the machine, but you get access to the database. But you still know that there's like what kind of server is underneath. And then the database like services evolve even more, where you don't care about servers at all. You don't know how many servers are there. You get a scalable database that scales together with your demands, like DynamoDB or Cosmos or Firebase. You pay as you go, pay per request, pay per storage, pay per usage, and that's the next level of databases that most likely your serverless functions should be integrated with at the moment. Another use case another pattern that actually I used in a couple of setups is database in a function. The thing is that there could be some use cases when your database is mostly read-only. It changes infrequently. Basically, it's a predefined data set that you maybe change every day or every week. And then it means that you can just package that database together with the function code and deploy it together with the function archive. And this may seem crazy, but it actually works, because I mean, the only thing that, especially with Lambda functions, with the Amazon Lambda functions, you pay a bit of time of cold starts, because of course you have to initialize this 100 megabytes, you have to put it in memory. But when the Lambda is initialized, and if you have enough traffic incoming into your Lambda function, then you have enough instances, and all of them are hot. All of those the Lambda invocations are working against the hot pre-configured environment, and that means that we read data from memory, and that's super fast. Right. So I guess I'm running out of time. And just one more note. One example of using this the database as a function is DevTube. We basically it's an open source product that we did. We're running the whole index of the videos inside a function. That's I think it's a nice use case. Right. And
you can definitely share the slides later with the community. So
I have many.
If you have maybe a way to just really again, it's not at the minute, but yeah, try to find some good way to finish it all, maybe.
Right. Yeah, I have some security patterns which are mostly obvious, and Yes, just I mean, serverless actually is changing a lot of things in the way we think about software, in the way we think about architecture, and it's definitely also changing the way we did structure and design our code. And I think it does that in a good way, because it makes you more disciplined. It makes you more thinking about the cost of running your application in production. Despite of all fuss that serverless is kind of removing operational aspects, actually it's making them more convenient, but it's not removing them, and it's making them actually more visible. And you as a developer becoming more like DevOps person who is aware and is capable of deploying scalable application without by themselves. Right. So that's my conclusion. Thank you very much. And so sorry for the rush. I'm doing this talk for the first time, so maybe I just.
No, thank you very much, Andrey. I understand why you were rushing through it as well. You have a lot of material. That sounds awesome. Yeah, indeed, we have two speakers, so time is a bit limited. But we started a bit later as well, so it's not like you really blew through it or whatever. So and if it's your first time, I understand that needs to be calibrated. But we're happy to do this as well as Software Circus. It's just meetups.
Thank you.
So if people have questions, let's check the chat. And feel free to unmute yourselves if you have questions.
Yeah, there was a question. There's a question about what bad serverless pattern that came up. Oh, well, the worst one is probably is about security. So there are many serverless functions at the moment which are running completely without any authentication. And that's definitely something that you should also think about from day zero. And then the funny thing that most of the platforms like Amazon and Google, they actually allowed you to deploy authenticationless functions from day zero, and they didn't enforce you the authentication by the rules. Now they are enforcing that. But in the first days, it was it was really like Wild West. You could do whatever you want. Another anti-pattern is probably, you have to think about security in big time, because well, it may seem very, very simple that you just write your code and the code is very small, and then you deploy it and then it runs. But then you don't think about, it's different types of injection attacks, SQL injection, cross-site scripting and stuff like that, replay attacks. And you have to think about that, because as soon as your function is available on a common platform, and you have an endpoint and anybody can call it, you have to make it secure. That's absolutely. So request signing and stuff like that. Yeah, and also another one that is kind of funny, that if you make a recursive call of your function, then most of the platform actually don't protect you against that. You will be billed for that. You will have to pay for that.
We had another one from Mikola, if I pronounce your name right. How much optimizing the cold start is too much, and do you have examples?
Well, not at the moment. I mean, I don't have example, but the thing is that I usually one thing that you do when you do optimize for cold start, you try to minimize the dependencies in your code, because usually the dependencies that you have, like libraries and any initialization logic, would require some start during the cold start. And if that optimization, if you feel like removing important integration from the function is actually making the function less useful, then that's too much. Then most likely maybe we should move that function to a container and run it inside Amazon Fargate, for example. And have more memory, more CPU available to the function, so it can scale in different in a different manner. But if you feel like you are cutting too much business logic out of the function, then it's too much. I would say. And if instead of creating a consistent, coherent code unit, you start creating too many small units that are very hard to maintain, that's another like too much. So the code should be simple to understand. The deployment should be simple to understand, and at the same time, it should be simple to scale and then run. So you have to find the balance. And when the balance is lost, then it's too much, obviously.
Thanks. We have another one. When should switching to Lambda be considered, EE instead of EC2 instance? I don't know if you can see the questions in the chat as well. I don't know if I do them justice.
To answer that, actually now, if I start doing a new project, I would actually first try to make it to try to architect that as a set of Lambda function or a set of consumed services, because then it means I can actually most likely do it alone or do it with a small team of people. I don't need anyone to help me out with configuring operating systems and networks and stuff like that. I mean, I know how to do the other thing as well, but still, I would try to start with serverless world to see whether this fits my use case. And in most of the cases, it does fit my use case. If I see some special uses, some special parameters, some special performance requirements, for example, or some special legal requirements, then it could be that I will actually run it as a container or as a real server. But my current path is that I first will start with serverless, see if it fits, and see if I can delegate my database to a service, my messaging to a service, my mailing to a service, and if it does, I'll do that. If for some reason it doesn't, then I will go to more low level in infrastructure.
All right, we have a couple more. We have a couple more minutes. So Dan is asking if there are situations when using serverless as a model is not a good fit or becomes more expensive financially.
Well, if your performance requirements are very high. So, for example, high frequency trading is probably not a good use case for serverless. Because in high frequency trading, you have to be sure about the latency, for example, because the deals have to be made, the transaction time has to be very small, and that has to be very predictable. Serverless platforms may have some lags, may have some spikes that are okay for normal users, but are not okay for high frequency traders, for example. Also, if you do some sort of very heavy image processing, which requires a lot of CPU, then well, serverless environments or container environments also may not give you that amount of CPU, may not give you access to the GPU if it's needed. So in that case, of course, you have to go into more real VMs or real hardware where you can do that. So serverless is not suited for everything, but it is suited for quite many things. And if you take a normal, a small or big company, medium company, majority of use cases actually can be covered by serverless deployments. Unless you're building some sort of platform for, if you're on Netflix, most likely you will not benefit from a lot of serverless things running in Amazon, for example.
All right, one more before we turn to Jojo's talk. I'll let you choose the ones from the last couple of questions from the chat, and then maybe you can answer the second one by chat after this.
So I'll take the one about programming languages.
Okay.
Right. If you plan to try different cloud providers, different platforms, then I would say Python or Node.js are the best options. But if you are a Java programmer or C# programmer, there still are options for you as well. So I mean, it should not be a problem to try any language out there. Just Python and Node.js are probably the most implemented ones across different platforms and the most supported ones. Also, it is quite common that the frameworks that allow you to make quick deployments, like serverless.com, for example, or some others, they also are implemented in Python or Node.js. So you probably get more experience there if you try those. But a couple of years ago, Java was not really suited. I mean, it was okay for running some types of serverless flows, but because of the fact that Java has very long startup time, like a JVM has, because of JVM design, It was not really suited for like, fast response, request response operations, but now they kind of solved that with GraalVM and stuff like that. So definitely the things are evolving there. Also now most of the platforms actually support custom runtimes. So if you have very specific requirement for every specific like library or type of like Python version or Java version or I don't know, .NET version, you can actually create your own runtime and deploy it to the platform and then start your functions from that. So possibilities are endless. Yeah, there was also a comment about 10 minutes about Lambda function in Amazon. Actually, I think now it's 15 minutes. And if you take other platforms, it's even bigger. So in some platforms it's 20 minutes, in some platforms it's unlimited. Right.
All right. Thank you very much, Andrey.
Thank you.
And yeah, please feel free to keep answering the questions. I see there's another comment either, like, and feel free to continue chatting everyone about the topic. But now we're going to give the space for Jojo, who's going to talk to us about the state of open source serverless.